Welcome back. We are now doing question 2. Here we are given 2.1. Here we are given x plus 2 close bracket x minus 3 close bracket less or equal to, and no, actually less than. It's not a less or equal to, just less than. Negative 3x plus 2. Okay, now what I want to suggest here for us quickly, is to focus on what the question says. It is very important when you do that. And this type of question, you must understand that pardon me, these are inequalities. Because these are inequalities, there will be a requirement for you to actually construct a diagram, inequality graph. Now let's go right to it. 2.1.1 solve for x if that's the same thing, the very same thing on the above. Now how are we going to do that? What you must understand here is that this inequality sign, like I always say, treat it as almost your equal sign. On your mind, put it, replace this as an equal sign on when doing your solutions. This helps you to understand one aspect, that you can transpose things to the other side of the equal sign. Okay, so let's expand the bracket because we have to solve for x here, and the way it is currently, it won't help us. We'll need to solve this bracket. So x times x, x squared. X times negative 3, negative 3x. We're done with that. This multiplied this, they multiply that. Then the second term of this. 2 times x, 2x. Signs are very, very important. Positive 2 times negative 3, negative times positive, negative. So negative 6. Don't get a mistake of adding them and getting a negative 5 here, or getting a 1 or whatever, something of that nature. Be careful that you're multiplying because of the brackets. Then whatever remains is that I believe that I must show you this step. So I've just expanded the bracket, then I write whatever was there, minus 3x plus 2. Then if you treat this as an equal sign, and I'm gonna try to find a different color to highlight that, you have that upper hand, if you're gonna understand the purpose of it, to actually pretend this is an equal sign. If you have that on your mind to pretend this is an equal sign, this inequality sign, then it allows you, it gives you that ability to transpose, to apply the rules of transposing terms to the other side, so that you're left with a 0 on the right hand side, which will then mean that this goes to the other side, becomes a plus 3x, this becomes to the minus 2. Still the same sign. All you've done is just taken things on the other side. This sign won't change. This sign only changes when you're dividing. Then the sign will change. But that's something of another day. At this point, collect like terms. Okay, the ones with the x's, this one, and this one stand together. So this cancels with this. Then I'm left with 2x. And then this and this add up. Let me do that now for you. Plus 2x. This 2x, then you've got a negative 6 and a negative 2. Of course, the signs are the same, nothing changes. They are not multiplying, so it will be negative. Then you just add the terms then, which is 8. This gives you what? This gives you less than 0. Then, ladies and gentlemen, now at this point you have to see this as a trinomial, or if one would want quadratic, it's fine, you can put it that way, it doesn't matter. But the matter of the fact still remains this: you have to have two brackets. I've done the explanation of factorization in the previous video. Go back to question 1. I did a similar problem like this, so I won't exhaust my time on that one now. I'll just give you the factors here. These are the factors. So what does this mean now? If you would then apply that knowledge at the back of your mind, this must mean one thing and one thing only. It means that the value of x will be this in an opposite sign, and the value of x will be this on the other side. So what does that mean? It means the following, and I really wish that you would imagine it the way I'm actually telling you. You then have to understand that if you have this as an equal sign, x, and I'm gonna put it in a black ink again for the fact that it's not what I'm writing here, but for the sake of understanding, x is equal to -4, or x is equal to, opposite side of course, plus 2. This, ladies and gentlemen, only means one thing. It means that these are what you can call your critical points. These are your critical points for what? For your graph. So when you have to take it back and apply it, this is how you're going to apply it. You construct this function with the line, normal line. Once you have that normal line, you put this value, -4 here, you put this other value, +2 here. Then this graph, this function, this one, must be represented here as a parabola. What type of parabola will this be? This will be a parabola facing up. It's a parabola facing up. Why? Because the value here is positive, which means that it must have a turning point somewhere, somehow here. So it must come up something like this, turn here, join here. Now I want to repeat this again for you. This has been found through the aid of these values. It doesn't mean that they are equal to that. In actual sense, it means that x, in actual practicality, x is greater than -4 and less than +2. So we are looking at this region here. So x is less than, is actually greater than, sorry, x is greater than, x is greater than -4, which means it goes to this side, and x is less than +2. That's what this graph means. It means that it goes that way and it goes that way. So we are interested in this region here. One can write it as -4 means exactly the same thing, ladies and gentlemen. Okay, once again, you can take time to discuss this solution whilst I'm just going to be cleaning the board for you. Okay, let's look at question. Let's look at question 2.1.2. What does this question ask of us? Hence or otherwise determine the sum of all integers satisfying the expression. So you need to satisfy the expression x squared plus 2x minus 8. So from what you found previously, we found previously that x should actually be greater than minus 4, and then we found out that x should be less than positive 2. So x must be less than negative 2 and greater than. X should be less than positive 2 and greater than negative 4. That's what we have done. So we need to write this as a combined thing. That's what they mean. So you put your x in the middle. Once you've put your x in the middle, you then decide the greater sign. This means greater, it pushes it out. So it pushes out what is small. So it pushes out negative 4. So x pushes out, which means x greater than negative 4. But the same x is pushed in by positive 2. I mean, I'm using the push in terms here to kind of explain it better to you in a language which I believe we can all understand. So I know when I was a student back in the years, I also used to struggle on how to write this as an expression which satisfies the above given solution when they say hence or otherwise. What they mean is whatever you have came up with on the above statement and has satisfied your expression or your equation, then write it as a combined expression now, which means that x must be greater than negative 4. So x must stay in the middle, greater than negative 4, but x must be less than positive 2. So x, the same x, less than 2. That's what the examiner was expecting of you here. Okay, I'm going to wipe this out and quickly rush to question 2.2. Now let's look at question 2.2. For 4 marks, this question scores you or requires of you 4 marks. You can score 4 marks here. What does it say to you? It says simplify the expression fully. Now what you have to understand here is that you cannot just go on and add here and to the power 2x and cancelling the zeros and all. I mean, the ones you get a 0 and all of that. No, don't do that. Those are shortcuts, and for 4 marks, of course, that's incorrect. So what do you then do? You have to understand that when you multiply in terms of the same basis, you add the exponents. Multiply in terms of the same basis, which means that this 4 resulted from another 4 with a power of -1. If you can have that in mind as an understanding, because that's where those powers ended up being combined. There was a rule of multiplying in terms of the same basis, adding exponents. Then which means that this x must be a power of this 4, and then this 4 must multiply another 4, which has a power of -1. With that in mind, you do the same thing here. All over 17 times. Now let's understand that 12 to the power x can be split as multiples, which will eliminate one of the numerators, and that is 3 to the power x. When you multiply terms of the same basis, you add your exponents. So this x is not squared, it's just an x of the 2 of the 4, I mean. So it must be 3 times 4 to the power of x. Only the x must be on a 4. Why do I say this? I say this because of this. 3 times 4. So you multiply in terms of the same basis, you're going to add exponents. If you add the exponent when you have an x here, it's going to be 2x. So you don't have to have an x here. But the bases also are not the same, but these are numbers rather. So that can also give you a problem if you're not looking at that. So you have just separated these two. You just separated these two, and then what does it give you? It then gives you this 4 to the power x cancels this 4 to the power of x, and then this 4 to the power of x is cancelled with this. I mean, you could have taken out them out in a bracket so that they can clearly cancel, but you can actually see it without writing the bracket down. You write what is left, or what is remaining. 4 to the power of minus 1. The plus sign is this plus sign. 4 to the power of 1. All over 17.3. Okay, so 17 times 3, what does it give you? Now, I want us to understand one thing here. The next step is that you have this power, or you have this exponent of a negative number. What does it mean? It means that this must go and be a denominator. That's what it means. So 1 over 4 plus 4, this 4, all over 17 to the power of 3, I mean times 3. Then you will see that now you have fractions which are adding with the numerator, you are adding fractions which are not the same, and in order to make this work, you need to multiply by the fraction which will make this one you need to multiply by the number which will make these fractions identical, and that is, I want to do it the old school way. I don't want to skip anything. So 1 over 4 resulted from a negative, a power of a number with a power of a negative. It's going to be written like this. This is the same as that. Then let's make these denominators identical. Multiply by 4 throughout. 4 times 4 is 16. So 1 over 4. This plus, you're timesing by 4. Why do you times by 4 in this numerator? Because you want to adjust these denominators to be identical. Hence I said I want to do it the old school way. I mean, people have different ways of doing it, but why doing it quick if you're doing a video to explain to people? That's my argument. So 16 over 4. 4 times 4, 16 over 17.3. Now I'm gonna summarize some spaces, but you can see one thing here. 1 plus 16 is 17. So this whole thing, I'll write an equal sign because it goes that way. 17 over 4 over 17.3. This we can also say divide by 1. Then let's multiply. Let's multiply then, which means that this will then be equal to 17 over 4, this 17 over 4 multiplied by 1, this 1 over 17 times 3. This is an old school multiplication method. and I'm going to explain it here. A over B divided by C. You can't say that. I'm going to try to write it up here. Let me just explain what I've done here. A over B over C over D must be equal to A over B, which is the old numerator, multiplied by D over C. I mean, you should have done this grade 10, also here in grade 11. So this is what I've done here. I'm applying that rule, but I don't want to confuse your focus now, so I'm going to take this out. It's gone. Then that's how I got here. Then we can see that this cancels with this, which is your final answer will be 1 over 4 times 3, 12. That's your final answer. 1 over 12 is your final answer. Then I believe that this first part of question 4 is done, but I still have to go on to further do 2.2. Once again, you can discuss the solutions and wait for me to go on. Okay, let's then go to 2.2. They're saying here, if this is an old school kind of a question back in the day, where they want to confuse you, where the examiner wants to confuse you. They're saying here, if 3 to the power of minus x is equal to 40, express this in terms of t. What does the examiner really want here? The examiner only wants one thing here, and one thing only. We have found out, and I want to clearly explain that. We have found out that this whole thing, this whole solution is equal to what? Is equal to 1 over and then because of that, we have found out that previously that 1 over 12 to the power x. Because of that, we then are able to say 1 over 4 times 3x, 3 to the power x rather, is the same as that. Then we are able, because this is 1 mark, we are able to say that 1 over 4, right, times this is here. So times 3 to the power of x. Why is the power of x changing here now? Because it's changing because of this. It's changing because of it's going from the denominator to the numerator, which then gives you 1 over 4 times 4t. So in actual terms, your answer here is equal to 4t over 4, which is equal to t. Okay, 2.2.2 is done. I'm going to wipe this out and then do the simultaneous of x and y. Okay, so let's work this out. We're given that. That's what this part of the question paper asks of us. I just felt like copying it out nicely for you. Solve for x and y from the given equation. 3 to the power y equals to 81 to the power x, and y equals to x squared minus 6x plus 9. Nice problem, very, very beautiful problem. What do we need here? We need to understand the concept of exponents. This is what we need to understand. We can write 81 as a base of this number. How can we write 81 as a base of 3? Let's try it out. So I want to write 81 as a base of 3. So let's try it this way. 3 times 3, that's 3 to the power 2, is 9. Times 3 is 27, so that's 3 to the power 3 times 3, it's 81. So 3 to the power of 4 is the answer. So 3 to the power of y equals to 81 is changed to be 3 to the power of 4. Then that x still stays there. Then what do we get? We know that when the base is the same, your exponents will be your answers. So therefore, y equals to 4x. This is the third equation. This was equation 1, this was equation 2, this is the third equation. Once you have derived your third equation, it's a matter of substitution. So they said that in this equation y equals to that. So what we can suggest then is that sub equation 3 into equation 2. So this is equation 2. This is equation 2, and of course this is equation 1. Where you see y, you put 4x. Let's go. 4x this equals to simple. Collect like terms. This must go to the other side. Let me continue here. So 0, this goes to the other side, is equal to x squared. When 4 becomes negative with a 6, becomes negative 10x plus 9, which was already there. Once you got that, it's a matter of factorization. Take the factors. So we want to factorize here. Factors of x are x and x, or x squared are x and x. Factors of 9, which must give you a 10, it's 9 times 1. So this 9 is positive. Factors of this number, which is positive, to give you a negative middle term, they must both be negative. So it's negative 9 times negative 1. Those are the factors of this number which will give you the middle term. must be equal to 0. So what does it say? It says x is equal to positive 9 or x is equal to positive 1. You can substitute in any of those equations to find that value. So you can go back to equation number 3. So substitute x into equation 3. What does that mean? It means that you go back to equation 3, y equals to, substitute for the first x value, 4 times 9, which is equal to, or what other you can say, and, don't say or, you can say and, y equals to 4 times 1, which is equal to, so 4 times 9, we know that 4 times 10 is 40, so 4 times 9 should be 39. My bad, 36, because you subtract a 1 from each of those extra 9s, you've made a 10. 4 times 9 is 36. You can easily find that if you don't have a calculator. 4 times 10, the nearest number to 9, so, which is 40. But from the 40, you added extra 1s to this 9. But how many were those 9s? Were 4. So 40 minus 4 is 36. Then 4 times 1 is 4. So those are your solutions. Now, you write it how? You write it in coordinate form. So this value comes from a 9. So in coordinate form, x, so in coordinate form, you have an x as a 9 and a y as a 36. And also, you have an x as a 1, you have an x as a 1, you have an x as a 1, and a y as a 4. Those are your solutions. You've written it in coordinate form. Okay, now we have solved the end of question 2. Watch out for the next videos for question 3 until the last question, I believe, is question 5. Stay tuned.